is the solution for quiz 5, and this is another step along the way of putting everything together to do the linear programming problems. So this is the finding the feasible region and then finding the corner points of the feasible region. So we need to graph this system of linear inequalities. So I'm going to number them just to help you be able to follow my work. So linear inequality number 1, the first thing I need to do is graph the equality of the line. And I'm seeing that this line would be a good candidate for the intercept method, so that's what I'm going to do. When x is 0, y is 3, and when y is 0, x is 1. And then I've done this problem already, and so I noticed that the feasible region comes out really small if I do 1 unit for 1 box. So I'm going to do each box as a half a unit that will, it's like zooming in on the graph. I'm going to spread it out more so you can see it better. So I have the point 0, 3 as a point on my graph, and the point 1, 0. And then I'm going to make some more points so I can make my line sort of straight. So that's my line, number 1, and I label it on the graph, and you'll see why later. It just helps keep track of my work. So then I need to shade one side. So I'm going to test 0, 0 in the inequality and say, is it true or not? Does 3 times 0 plus 0 come out bigger than 3? It's not true. So I need to shade away from 0, 0. So you can either shade or use the arrows. You'll see when you get a lot of lines going on, the arrows can be coming on easier to follow along in the shading. Okay, then the second line is already in the slope-intercept form, where I can see that the y-intercept is 1. And my slope is down 1 over 2, down 1 over 2. Then I draw this line. And it's straight. Okay, then for this line, because I have y by itself on one side and less than, I can just say, I know I need to shade below the line. So you can still do the test 0, 0 if you like, but it will give you the same result. So I can see that I need to shade below the line. So now, if I think of these two lines as creating 4 regions of the graph, here's the first region, second region, third region, and fourth region. You can see that in the first region I have purple only, so that can't be the feasible region. The second region I have neither color. In the third region I have green only. So it has to be in this triangular area down below to the right so far. Okay, now I need to incorporate the information that says x and y both need to be positive. I need only the part in quadrant 1. So that's going to give me a boundary for my feasible region on the x-axis, which is the line y-axis. So now I can see my feasible region is this little triangular region. So I need to see evidence of how did you decide where to shade, your shading, and then make your final feasible region here. Okay, so that's find the feasible region. Now there's one more step, find the corner points of the feasible region. So I'm going to label them here. I usually use the lower left point as my beginning place, and that's A, and then I'm going to label this one in the upper left, B, and this one in the lower right, C. If you found one of the points as part of your graphing, then you can just state what it is. So I can just say point A, I found that when I was graphing line 1, so you can maybe see why I would use a different color and label line 1, so I know that's the x-intercept of line 1. So I know it's the point 1, 0. Okay, then B, I'm going to have to use some algebra and find the intersection of the two lines. And then C, I actually have to do some algebra too, because that is the x-intercept of the second line, and that's not given. You need to find it, so don't trust your eye, use algebra. Okay, so to find point B, I need to find the intersection of the two lines, 3x plus y equals 3, and y equals -1/2 x plus 1. Finding the points of intersection of two lines is exactly the same as solving the system of equations. So this is a system of linear equations, and I'm going to use the substitution method because the second equation is already solved for y. So I'm going to substitute that into the first equation in place of the y, and get y equals 3x plus -1/2 x plus 1 equals 3. So I have the 3x plus the y equals 3. So 3/2 x minus 1/2 x is going to be 5/2 x plus 1 equals 3. Solving for the x, 5 times x equals 2, and we'll multiply both sides by 2/5 to get x by itself, and x is going to be 4/5. So let's go look at the graph and see if that seems reasonable. So for point B, this 4/5 seems reasonable for the x coordinate of that point. It's almost to 1, to multiply. So that's pretty reasonable. Well, now I have an equation that says if I know what x is, here's how I can find out what y is. So y is going to be -1/2 times this x, the 4/5, plus 1, so that's going to be 3/5. So the point B is 4/5, 3/5. So that's our corner point. And see if that looks reasonable in the graph here. It's not a great graph, but that's pretty reasonable. Okay, then for C, you need to find the x-intercept. So you set y equal to 0. X-intercept, so you're going to say, when is it true that 0 equals -1/2 x plus 1? Subtract 1 from both sides, and you can divide by -1/2 if you like, and you're going to get that x equals 2. So we found the x-intercept by setting y equals 0, so the coordinates of this x-intercept are 2, 0. So this is the answer to the question, what are the corner points of the feasible region? So then the last step in a word problem would be to find your objective function and evaluate your objective function past each of these points. So let me know if you still have questions. I'm happy to answer.